Okay, welcome OCCC automotive students. This is going to be part 2 of our basic electrical operation, testing and so forth. In the last video we got started with this, have the same circuit here still, and we're going to make some more measurements and talk about some more parts of the circuit. So just as a little bit of a review from part 1, we have a power supply inside our box here, okay? And it provides us about 12 volts, okay? We can look up here and we can measure, it says 12.06 volts DC. So I have 12 volts coming out of there, and then we have our ground connected down here at the bottom, okay? And so we have our power supply, we have our circuit protection, which is a 10 amp fuse in this circuit, and then we have our control device, our load, and then the wire to ground here. There's a ground here that actually goes right back to our power supply, just like it does on a battery on a car. Okay, so we have our 6 parts, and also then the insulated wiring. So we have to have those 6 parts for every circuit. Okay, all right. So we looked at that last time, and then here is just a little bit of a review for that. 6 parts for all series circuits, okay? And they have to be connected. Here we call it series, okay? They're all in line with each other in series, or single file, you might say. And then the ground here at the bottom, actually inside the board, goes all the way back up here to here, and it makes a complete loop, or complete circuit. So anytime there's an open in the circuit anywhere, then the load will not operate. If we disconnect the ground, it doesn't work. Can disconnect it there, we disconnect it there, it won't work. If we disconnect the power side, then it doesn't work. If we turn the control off, we have in effect created an open in the circuit, but we did that on purpose, okay? That's the point of the control, so we can turn it on and turn it off. So if the circuit is on and the fuse happens to open, we call that an open fuse or a blown fuse, then the load ceases to operate also. Okay, so just a little bit of review of that. All right, we also mentioned in the last part a little bit about Ohm's law, okay? But and the relationship between volts, ohms, and amps. And I have, let me get that real quick. Here it is. So, Ohm's law, okay? So, in this formula here, E represents voltage, okay? And I represents current, and R represents resistance, okay? So we're going to talk more about that and do some worksheets on that. But right now I want to define some of these elements of the circuit, and that would be the volts and the amps and the ohms, okay? So I mentioned in the first video that voltage is thought of as pressure, okay? Testing and measurement here. All right, so volts, we use a voltmeter, which is like this right here, okay, to measure voltage. And typically on a vehicle, it's between about 12.6 and 15.5 volts, okay? That's going to be your range. Normally on body electrical stuff on an automobile circuit, okay? Amperage is measured with an ammeter, A-M-M-E-T-E-R, not an amp meter, but an ammeter, okay? And we use the same meter right here, but we just put it in a different setting, and it will measure amps also. And on a vehicle, that's anywhere from about 3 amps to about 200 amps. Is going to be the range of operation there, okay? Excuse me. And then we have ohms. Ohms is anything that we measure ohms, and it is the resistance to the movement of the electrons or the amps in the circuit. Ohms is measured in, or resistance is measured in ohms, I'm sorry, and that could be anywhere from 0 ohms, no resistance, to infinity, okay, to something you can't measure, okay? So typically on a car though, we're going to measure a circuit, and it's going to tell us to measure to see if the ground is less than 10 ohms or something like that. And so each component on the board here has a predictable, if you will, amount of resistance in it, okay? And it can be measured, all right? So we have volts, amps, and ohms. All the measurements then are made using a combination meter, okay? All measurements are made using a combination meter referred to as a DVOM, which is digital volt ohm meter, or simply a digital multimeter, DMM, sorry, which looks like this right here, okay? So we've measured voltage, and we've done that before. So we got 12 volts there, 12 volts there, 12 volts in front of the bulb, if you will. And if you remember too, that after the voltage passes through the load, then it drops to near zero, okay? That's because the load consumes the voltage. Now the interesting thing about that is that the voltage stops, if you will, because it's just pressure. It's like pushing against something. And once it gets through the load, then the pressure's gone. But the amperage is still there, okay? And so we want to take some measurements here and show you what amperage looks like, okay? So let's unplug that. And we're going to unplug this right here. Move this over. Reconnect the circuit. Okay, so to measure amperage, we must intentionally open the circuit and put our meter in line with the circuit so that it will measure amperage, okay? So we got to move the red lead over here to the A position, okay? And it didn't like where I had the knob at. So we're going to move it over here to where it says MA or A. Now we have the meter set on DC amperage. Okay, so in order for the meter to actually count the number of electrons going through the circuit, it has to be placed inside the circuit, just like the bulb is inside the circuit. It has to be in series with the circuit. So we have to open the circuit, okay, in order for it to work. All right, let's move this over here where we can see a little better. So we're going to open the circuit with our jumper leads here, and then we're going to put the meter in the circuit. It's going to become part of the circuit, all right? So we do that, our light bulb comes back on, and now our meter starts counting. See what it's reading? It reads 0.322 amps. So this is basically 3/10 of an amp. Okay. Oh, there's a glare on the meter box there. See if I can move that. Sorry about that. Still got a glare on it. How about there? That's better. Now we can see it. Not bad. All right. So it's reading 0.319 now, so let's change this a little bit. They're amps. So it is actually counting the number of electrons that go through there. And amps, 1 amp is a large number, but we'll talk about that in class. But the point is here, in order to measure the amperage, how many electrons are flowing through, we got about 3/10 of an amp. Okay? All right? And that's expected on a bulb this size. All bulbs are rated in amperage and watts, voltage, and so forth. Okay, so that's measuring amperage. So in order to do that, you have to do a couple of things. All right, you have to open the circuit. Okay, and then you have to put the amp meter in there. Now the interesting thing about amps, we said voltage is consumed here, but amperage is not. So we just measure the amperage on the ground side actually. Okay, now if we measure it on the positive side, so to speak, by doing that, we still get the same thing, 0.323 amps. So the rule for amperage is that in a DC series circuit, the amperage is the same anywhere in the circuit. That's the rule, that's the law. Amperage is the same anywhere that we want to test it. Okay? So you have to set the meter to check amps. You have to move the lead over here. The black lead always stays in the common. The black lead always stays there in any of our measurements. But the red lead does move back and forth sometimes. All right? So we've got it set on amps, and we got the lead on amps. So it's the same anywhere in the circuit. Now the next thing to measure amperage is that the circuit needs to be on. It has to be working. The electrons have to be flowing. Okay? I say that to say that when we measure resistance, the circuit needs to be turned off. No amperage, no volts to measure resistance. Okay? All right, questions so far? Hook that back up real quick. So anywhere we want to break this connection, we can measure that. All right, I'm going to move this back to volts for a minute. The meter will beep at you if the leads do not match your setting up here. It'll let you know if you got it set wrong. All right. Let's see if we got that where we can see it. Yeah. All right, so we go back to previous deal here, and we have voltage, right? 11.9 coming in, not much coming out. All right, very little. All right, now if we want to measure the resistance of any of these parts, we have to turn the circuit off, okay? Circuit has to be off, and basically the component needs to be in your hand, so to speak, to measure it. So in other words, it's not operating, it's not on the deal. So the only thing we have to do here is to change from volts, not amps, but ohms. Ohms is identified by the omega symbol on the meter. Okay? So we moved it to ohms. See the omega symbol? Now it reads ohms over here. It says M ohm over here. Mega ohms. So right now it reads OL. OL is a lot like infinity. It means it's out of limits. So if we want to measure the resistance of this bulb, that's a good thing to measure or check. We can do that. Okay? We can do that. All we do is put the meter across the component. One side to the other side. And we're going to measure the resistance. All right? And it says it's about 14 ohms. 14.4, 14.2 ohms. Okay? So there are specifications for that. All right? 13 ohms. Okay? So that's a good reading for a bulb. Okay? We can also measure any of our other components here, even like a wire. So we can measure the wire coming from our circuit protection to the switch, and it reads 0.02 ohms. Now, that is predictable. We would expect just a piece of wire not to have very much resistance. Okay? That's how they're made. Not very much resistance, sorry. All right, now our switch here, let's unplug this at the top. Our switch here right now is OL, is open. Let's close the switch, see what it reads. It reads about 0.5, 0.6 ohms. Actually, it reads about 0.2 if we got a good connection here. About 0.5 is the limit for a manual electrical switch like that. Okay? When we open it, we can test this switch too with the ohm meter, see? It goes open, and then it goes closed. So that's a test for the switch itself. Follow me? Okay, so that's resistance in ohms and measuring that. Okay, so all that requires the use of the same meter, digital multimeter. We just change the settings and then the meter knows what it is we're going to test. Okay, all right, what do you think about that? So to measure voltage, we have to have the circuit has to be hot, so to speak. It has to be live. Okay, let's change this back to voltage. All we got to do is change that back over here. Plug it back in. What happened? Nope, I got it unplugged over here. And over here. So we can measure voltage anywhere along the circuit. Now, if we have unexpected voltage on the ground side, then that indicates a problem. So we'll talk about that here in just a minute. Well, we got a minute here. Let's go ahead and do something else real quick right here. Let's add something to the circuit. Let's add another bulb to the circuit. Okay. All right. So this bulb is in series still. Voltage is flowing here, 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 here. Or is present there, I should say. Amperage is, the amps are flowing. The voltage is present. Voltage is present. Okay, so let's test that. So we still got our 12 volts up here. Still got it here. Still got it here. And we still got our 12 volts coming into the first bulb. Okay? Still have our 12 volts coming in the first bulb. But in our first circuit we had, when we just had one bulb, okay, the bulb used all of the voltage. Now we have two bulbs. And if you notice, maybe you can tell, the bulbs seem to be dimmer now. So the voltage, the change in voltage across a load is directly related to the resistance in the whole circuit. Okay? So, if we split this in half, I would expect to see about 6 volts here. 5.7. Okay? So, we still have some voltage coming over here because we had to operate this bulb when we put it in. Okay? All right. So we got 6 volts coming out of that bulb. 6 volts going in, almost, about 5.7, into the second bulb. And then it's still going to consume all of it. And so we've got very little coming out the second bulb. Does that make sense? That's a little bit of a new twist there. Okay? The circuit automatically adjusts due to the change in resistance. Change in resistance changed our readings, but we expected it to do that. Okay? And so again, that's because of Ohm's law, and we'll demonstrate that mathematically in class. Okay? All right? Now we can do something else here too. All right? We can measure the change in voltage at any 2 points in the circuit, right? I don't know if so we can check change in voltage across this switch, and there's very little, 0.002 volts. But there's going to be 6.2 volts drop there, and then 5.8 volts drop there. So the bulbs are not exactly the same resistance, but they're pretty close based on our readings. But if you take 5.8 and 6.1 and add it up, it's going to equal our source voltage of 12.05. That's another law that we're going to talk about in the next video. Okay? That's all for part 2.